Okay, example 4, we're going to find the inverse and then determine if the inverse is a function. Now find the inverse, I like to do the method where we switch the x and y, so x equals 2y cubed plus 1, subtract 1 both sides, x minus 1 is equal to 2y cubed, divide 2, and then the cubic root. Okay, so we have the cubic root of x minus 1 over 2 is our inverse. And to see if our inverse is a function, we need, maybe you recall the vertical or horizontal line test. In order to be a function of y, we can't have any points that give two inputs that have the same output. Okay, so what I mean by that is if I had a function like, I don't know, like this, and it comes straight down, it creates a straight line. Now that wouldn't be a real function that we know right now. But it's saying 1, 2, 3, 4, this is 4. If I plug in 4 for x, I can get multiple y values, right? Okay, so function means you have one input for every output. It's 1 to 1. Okay, 1 to 1. Okay, so whenever you put an input, an x value, you'll get a different y value. Okay, you can't have the same y value when we, x value for different y values. So horizontal line test is where you take your pencil and you hold it vertically, or sorry, horizontally, and you'll see, do I touch more than one point at once? Okay, let's look at our y cubed x minus 1 squared. Clear. Do I have a cubic root on here? I don't know if my calculator is fancy enough. But I'm happy to show you on Desmos. I actually could show you on Desmos. So we'll go to Desmos. Sorry, I should have had this up before. I thought my calculator was going to be able to do it. Okay, and so then we have cubic root. And we should be able to change this to cubic root. Wow, I guess I can't take it to a cubic root. I thought I could. Okay, I apologize for making the video longer and messy. But you can graph this in your own calculators, and yes, it will be passed as a function for your horizontal line test. Okay, and now we're going to, oh, that's it. Okay, next one. Now, example 5, we're going to determine the inverse of f is a function. So we have y equals 2 squared of x minus 3. We'll switch it, x equals 2 square root y minus 3. Divide 2 both sides, and then we'll square. Okay, so I have x squared. We can change this to 1/2 technically. And if I square both sides, I'll also be squaring the 1/2. So this will become 1/4 x squared for our inverse. Okay, then we'll also need to add 3 because this is equal to y plus or minus 3. So add 3 to both sides, and we'll have y equal to 1/4 x squared plus 3. Now, knowing about 2 square root x minus 3, when I graph this, I know the minus 3 makes me move to the right 3. So 1, 2, 3, and then I'm coming out like this. Knowing that my square root is all positive, but this quadratic, x squared plus 3, we'd be up 1, 2, 3. We know it'd be a quadratic like this. But because we're only positive for our range, then we need to limit our domain on this parabola to only positive x values. So let's say limit the domain to x is greater than or equal to 0, so that it's an inverse and it reflects over our line y equals x. Okay, reason I did that, one more explanation, is our square root is only positive. We don't have the whole entire parabola reflection, so we'll need to limit our 1/4 x squared plus 3 to positive real numbers for our domain, so that it's a true reflection over the y equals x. Okay, example 6, we have f of x equals 3x minus 1 and x plus 1 over 3. We're going to verify if they're inverse functions. Now to do this, you could rearrange your first one and solve for y. X equals 3y minus 1. Rearrange and see if it works. Plus 1. X plus 1 equal to 3y divided by 3. So yes, I can see that from rearranging. There's also a different way to do this using composition. Okay, and what you do is you take your original function, which is f of x, and you plug in your inverse function, and if it equals just x itself, then yes, they are inverse of each other. Okay, so my original function is f of x equals 3x minus 1. I'm going to plug in g of x, meaning wherever there's an x in my f of x, I'm going to put in the whole function g of x. So f of g of x will equal 3 multiplied by x plus 1 divided by 3 minus 1, right? Because we just plugged in g of x for x and my f of x. And we'll multiply through, I get 3x plus 3 over 3 minus 1. And I can simplify this to just x plus 1 minus 1, because our 3's divide by each other to get x plus 1. And then x plus 1 minus 1 is just x. Okay. We could also know that 3 over 3 divides out, and you're left with x plus 1. And there's our answer. We know we got x, so yes, they are inverses. And we also verified that by just switching the variables up here for this example. Okay, but main message is when you plug in the inverse to your original function and get x, yes, they are inverses. Okay, example 7. I think I'm going to run through this one really fast. I do have time. I have been going fairly quickly on the video. Also, sorry for the hiccup with the graphs. But here, example 7, find the inverse function that represents the surface area of s equals 4 pi r squared. Then find the radius of the sphere that has a surface area of 100 pi square feet. Now, to find the inverse for this one, really all we need to do, this is different than switching your x and y's, because we just want to find the radius. So we're going to solve our equation for the radius and turn it around instead of solving it for surface area. That's what it really wants in these kind of problems. So if surface area is equal to 4 pi r squared, we're going to solve it for r so that we can figure out the second part of the question. So divide 4 pi by both sides, and then we'll have s equals over 4 pi equal to r squared, square root. Because negative numbers don't make sense in the real world, we'll only have the positive of the square root of s over 4 pi equal to r. And then we're going to find the radius of the sphere when the surface area, or that has a surface area of 100 pi square feet. So s stands for our surface area, so we'll plug in 100 pi for our surface area over 4 pi. And 100 over 4 is 25. Pi over pi cancels out, so square root of 25 is r, so our radius was 5 feet. Are we in feet? Yeah, feet. Okay. All right, like I said, I did have to run through that fairly quickly. If you have other questions, let me know. Main message is finding inverses, switch your x and y, confirming if they're inverses, f of g of x. But I'm happy to answer questions. Have a nice day.